Now, let's solve question 3. I think we are done with 2, A and B now. So now, question 3 says what? Find the magnitude and direction of the electric intensity at the following point. We have solved A at the origin, we have solved B, 0.2, now. We are in C. Now, in C says was 0.1 x axis and y is what 0.15. If you are plotting graph normally, this is the origin, this is 0.1, you trace it up normally. Then this is 0.15, let's say 0.15 here, somewhere here. I mean from here, that is y. 0.15 from here. So you trace it. So this is a point now. That is 0.1, 0.1, 0.5, 0.15. Or you can say 0.10, 0.15. So that is the point. Now, at this point, now let's join it together with this. So you join this one together with this. So this is what we would have. This is a test charge. You place a test charge there. Now, if you place a test charge here, what will happen is this. Look at it. Let me write it here. 0.10, 0.15. Now, we need to calculate from here to this place. What is the value? We use what? From here to this place is 0.2 meter. Don't forget. Because 0.1 plus 0.1, 0.2 meter. From here to this place is what? 0.15 meter. 15. Now, this is positive charge. This is positive charge. You go anywhere you want to calculate electric field. I told you place the what? A test charge here. So if that is a positive now, what I want to do now is this one will repel like this in this manner. This one is E2. While this one is positive, they place a test charge here. It will repel upward now because this is plus, positive test charge. So I would have it like this up. This is what? E1. Now, this angle, so we can calculate for this angle because if you look at this thing, you're actually seeing a triangle. Look at it. This one like, is a triangle. So if that is a triangle, this is opposite of the triangle, and this is what adjacent. Look at it. If I draw it like this, look at what you are seeing here. This opposite, this adjacent 0.2 meter, this opposite 0.15 meter. So in that case, to find this place, now you use Pythagoras theorem. So which now give us what? 0.2 square plus 0.15 square. So square root of everything will give us here. I put using Pythagoras theorem. Let's say this A and there is B. So AB will now be equal to what? 0.25 meter. So this is what? 0.15 from here. So everything here is what? AB is what? 0.25 now. Now this is where the charge 10 to the power minus 8. First one, which is Q2. Second one, 10 to the power minus 8, Q1. So that's where they are. So if you want to now, we know the charge, the distance of this Q2 to this point now. This one, we say this one is going up. This one is going that way. You should show that's what I do. Now, for us to find this angle, you can say sine theta is equal to opposite over hypotenuse, which is 0.15 over hypotenuse, 0.25. That is opposite over hypotenuse. Then to find cos theta is what? Is equal to adjacent over hypotenuse, which is 0.2 divided by 0.25. Having done that now, let's resolve it. Don't forget that this angle is equal to this angle, corresponding angle. When you have two parallel lines and you draw a line like this angle is corresponding to what? To this angle. Don't forget. So that's what we are going to do. So this angle, now let's look for this angle. That angle is what? We have looked for it. We can look for here. Look at it here. You can get it from here or get it from here. But no need to waste our time. Let's resolve. So we have one going up. We have one going what like this E2 at an angle theta. Look at the diagram there. E1 is going up. If I resolve this what? E2 to the horizontal, what will it be? You close it. Abina, you close the angle, now be what? E2 cos theta, going this way. If you now resolve this one now, go up, now be what? E2 what? Sin theta. So now we now have how many forces? One, this one going up with this one, making 2. So our EX now be what? ES is only this, which is what? E2 cos theta. That is the only force that will now be the electric field that will be acting along the horizontal. Is what? 9 times 10 power 9. E2 is what? This charge Q2 times K naught, which is minus 10 power minus 9 times 10 power 9. Then divide by what is our distance from this Q2 to this test charge, the point where this 0.1 now 0.15, 0.25 all square. Cos, what is cos theta? Cos theta is what this now? Look at cos theta. So this cos theta just carry everything like this, everything, which is 0.25 0.20 divided by 0.25, and that will give you what? Your first answer. If you press your calculator, what do you have? 1152 Newton per coulomb. Then we look for EY. How many electric field is going up? Or 2? 1, which is what? E2 sin theta plus E1, which is already in that direction. That is what. So we're going to have what? 9 times 10 power 9 times 10 power what? Minus 8 over what? Absolute over what? What is the distance of E2? E2, that is E2. It's E2 now. E2 is caused by Q2. It's Q2. So you are going to have what? 0.25, which is the distance from here to here, 0.25 meter from here to here. All square. Sin what? Sin theta is what? What is sin theta already? 0.15 divided by what? 0.25. Plus, what is about E1? E1 is caused by Q1. The distance is from the test charge is for 0.15. So you have 9K, that's 10 power 9, multiplied by what? 10 power minus 8, which is charge, divided by what is the distance from that point? 0.15 all square. So what do we have if you add them, if you do the calculation? Press your calculator there. 4,864. Excellent. That means you are all following. Now, I haven't done that. Next thing we're going to do, class, is to find the magnitude and direction. And for us to find the magnitude and direction, what we are going to use is already an existing formula that we are going to use to find magnitude and direction. If you want to check that, you can check that in my vector analysis I did. Go and watch my video on vector. So for you to find net E net, now the square root of what? EX square plus EY square. That is the formula we are going to use. Okay, so we are going to have E net. What is the ES square? 1152 abi all square plus what? What is our EY square? EY rather 4864 all square. So what will that be our answer there? Approximately 5,000. 4,998. Have you now? Okay, approximately 9. Thank you. So that is about 5 times x power 3. Have you now? Okay, let's find the direction. Let's use this side. Direction is what? Tan theta equal to EY over ES. That is one. How do you find? Let's use alpha. You have already been using theta. Alpha. Alpha is direction of the resultant what? Electric what? Intensity. So this is what the magnitude, the net electric, the magnitude of the electric intensity. So that means alpha becomes tan inverse of what? What is EY? EY is 4864. ES is what? 1152. So if you find the direction, what do you have? Approximately was 77 degrees. So this is our direction. That is how this is what? Our magnitude. So for this question. So we have been able to resolve. Just note that you have to resolve, take note of the direction, resolve it up, take this one down. That means you are going to have E2 cos theta on the horizontal. Then E2 sine, so open it wider, you have sine. E2 sine theta plus E1 going upward. So that is it. Let's go to the last one. We move to the last one. Now, for this last question now, we are going to solve for what? The electric field at what? 0.1 or 0.1. I think I need to clean the board again. Sorry. To clean the board. Now, this are now, we need to quickly draw the diagram again. It is becoming too rough. This is what? 0.0. This is what? The charge where you place at minus 0.1, is 10 raised by minus 8 plus having 0.1 from the origin, meaning that what from here we place another one here, which is 0.1, having what? That means from here to the point of the charge is 0.1 meter to what? Plus 10 raised by minus 8 column. Now, we want to find the what? Electric field at what? 0.1. Now, what is 0, 0 is what? X coordinate. 0.1 is Y coordinate. So automatically means that it will be what? 0. X can only be 0 along the Y coordinate here. So let's pick here. So that means from here to this place is what? 0.1 meter. While Y is 0. That means this point is 0.1. So we want to find electric field at this point. So close it up. Close this one up. Now, when you do that, now that means that from here to this place 0.1, from here to here 0.1. So I want to find this place for me. So here will now be what? Okay, let's find this angle. Look at the board. Let me clean this side now first. Now, first of all, what is the influence of this charge on this test charge here? Yes, this is positive. This is positive. It will repel like this. This is, let's say, E1. This is positive. This is Q2. Don't forget this is Q1. This is positive also. And this is positive. It will repel like this. So we have E2 this way. Now, this angle should be equal, just like where we did the other time. Should be equal to this angle. And this angle here should be equal to this what? Angle. You know why there will be these two sides will be equal? These two angles will be equal. Look at it. What is opposite? 0.1. What is adjacent? 0.1. What is opposite of this one? 0.1. What is adjacent? So they are equal. That's why I don't bother myself. So now, if you resolve this one to this horizontal, it becomes what? E1 cos theta going towards this direction. If you resolve this one with respect to this angle, to this direction, it will now be what? E2 cos theta. Then if you resolve the two of them up, open it wide, opening the angle wide, will be sine. So I would have E1, this one is going this direction now. E1 sine theta. If you open this one too, open it up, resolve it up now, it will now be what? E2 sine theta. Now? So we have what? Two of them going up now. So EX, what is EX now? ES is what? E2 cos theta, which is moving forward. Look at it now. It's moving forward. That is going towards the positive direction. Then minus what? Because this one, when two vectors are moving in the same direction, opposite direction, you subtract. So it now be what? E1. What is our E1 now? E1 is what? Cos theta. Cos theta. So that is this. So which one now what? This one give us what? The same thing. Don't forget that cos theta is equal to what? Adjacent. Now, please let me calculate the distance. I beg. There's a need for us to calculate this distance from here to here. So how do you get the distance? Here is what? 0.1. Here is 0.1. This is a rectangle triangle. Eh? If that is a rectangle, let us find the hypotenuse. So how? That means we are going to find 0.1 square plus 0.1 square root to find what? Here is equal to this place now. Abina. So that means you get what the hypotenuse said, yes, of the both sides, and that will be the distance of the charges to where we are calculating our electric field from. To over what? That is in decimal points about what? 0.14. No, sir. This is 0.14. This is what? 0.14. That's what it means. Meter. So from here to here. So that's what I want to. Now, what is now cos theta? Cos theta. Let's use that idea that we use that time. Opposite over what? Hypotenuse, which is 0.1 over what? 0.14. Abina. Opposite over what? Hypotenuse. What about sin theta? Sorry. Adjacent over what? Hypotenuse. Sorry for that. It's a mistake. Adjacent over what? Hypotenuse. This one now is now what? Opposite over what? Hypotenuse 0.14. So haven't done that. 0.1 divided by what? Hypotenuse 0.14. No, this is what you are supposed to know. Opposite over hypotenuse. Those are basic knowledge. Now, we have done that. Now, let us what? We have resolved along the x-axis. Let's resolve along the y-axis. In the y-axis now, EY, we have done x. EY will now be two forces moving upward. Look at it. The result part of E2 going upward, the result part of E1 going upwards. So that means E1 sin theta plus what? They are going upwards, so the same direction, E2 sin theta. So that's what I want to use here. So now let's spread. This one will give 0. You know why? E1 and E2 are the same electric field now because they have the same charge and they have the same distance from there. The distance of this is 0.14. So distance of this is 0.14. What is the charge? 10 raised to the minus 8. What is the charge here? 10 raised to the minus 8. So the two of them, E1 is equal to what? E2 in this case. Then theta is this one. Theta is the same thing as theta here. So here will be 0 Newton per column along the x-axis. Then along the y-axis, we now have what? 9 times 10 to the power 9 times what? Q1 is what? 10 to the power minus 8 divided by what? The distance of separation 0.14 from that test charge. Now sin what? Sin theta is what? 0.1 divided by 0.14 plus, there should be square here, please. Then plus what? E2 is what? 9 times 10 to the power 9. Absolute of 10 to the power minus 8 divided by point charges. What is the E2? The charge Q2 from that point is what? C0.14. You see why I say they will have the same. This E2 and E1 will have the same charge, apart from this one that is now introduced. So this one now plus. And I told you why it's plus, but I'm going to say direction. Then 0.1 is sin theta divided by what? 0.14. 0.14. So what do we have now? Along EY. 6 point what? 10 by what? Newton per column. Have you now? So we have gotten that one now. What we are going to do now is E net will now be what? Square root of what? EX square plus EY square. And that will give us what? 0.0 square plus, which is along the x-axis, is 0. Along the x-axis, sorry. Now, along the y-axis, what do we have? We have 6.3 times 10 by what? 3 all square. So if you now press your calculator, what do you have? We are going to have what? Answer 6.3 times 10 by what? 3 Newton per column. That is our net. Exactly. Now, what about the direction? Direction without even wasting your time. If you want to find direction now, you use what? Let me clean this side so that I can solve my direction here. Okay, so you have to find direction now. Tan alpha, again, direction equal to what? EY. EY over EX. So alpha equal to what? What do you make of alpha? Tan inverse of what? EY over EX. So alpha is equal to what is EY? This. What is EX? 0. Anything divided by 0 is what? Is infinity. Then tan infinity should be what? 90 degree. EY is, let's say, 6 point what? 3 times 10 power 3. ES is what? 0. If you want to use calculator, you might end up not having answer. So then tan inverse, this one divided by 0 is 0. Is infinity. Anything divided by 0 is infinity. Then tan inverse of infinity is 90 degree. Is that clear? Is that correct? Okay, so that is just that. So this is what the right what solution for this. I believe we are able to what solve a lot of questions on just this one question, and it will clarify superposition, how it can vary or varies across what a particular field of electric field using superposition. So when we shall see again, same channel, enjoy your time. Thank you.